So this one is what? 1000 kg per meter cube, 1000 kg per meter cube. Do we know about the temperature? What is that? 23.7 degree centigrade. Okay. And 86,400, that's great. Now we need to find out delta, gamma, and lambda, and ES and EZ, 5 things, right? So to do that, we need to know the temperature, which is 20.7. So we kind of know that we need to do the interpolation. It is 20.7, it's not any integer number. So what we will do, I will skip the interpolation because I know you already know how to do the interpolation. So what I will do, I will just directly give you the value of all of this, okay? But all of those are interpolated. So from table 3.2 at 20 degrees Celsius, delta, gamma, and the ES. Okay.
So what's the
Most of the time, like soil heat flux, it's 0. It's not 0, it's actually insignificant. And I don't have enough information to find out the exact value. So that's why maybe instead of 0, like almost 0 will be the correct representation. Okay. Okay. So all of you have your table 3.2. Okay. What I will do, I will just go there. This is the table 2.2. We are looking for, what is the temperature? 20.7. So in between these two, right? So we will have, that is the ES, that is the, okay. All of these values are in between these two value. So I will give you the exact value, which I did by interpolation. Okay, so let's write it down. All of you, please mark on your copy that from where we got that. Okay, so I will just write down delta, which is 0.151, right? Is that correct? Is it within the range? And the gamma is 0.0668, and the lambda is 2.45, and the ES is 2.44 kilopascal. Okay. Now, ES is 2.44. We can actually find the EZ as well. EZ is relative humidity plus ES. What is the relative humidity you have here? 49%. So 2.44, which is 1.24 kilopascal. So now if you look at the equation, we have almost everything except 3 different R values, right? Is it correct, everyone? Okay. So we will work on that part. We need to find RS, we need to find RA, and the RN. Okay. So what we will do, since RN is the longest one, we will do that at the very last. Before that, we will work with RS and RA, and rest of the time we will spend on RN. Okay. Everyone's good up to this point? You have all the notes on your copy? Okay, okay. So I will wait maybe a few more seconds. Now, those who are done, can you open the page number 3 on your class lecture? There is a screenshot which contains the information about RS, RA, and everything. Right? Okay. Okay. So, determine RS and RA. Okay. So, as I say, the page number 3 on your copy. Do you have that on your copy, everyone? So here, if you look at the equation, we actually need 1 plus RS over RA, right? And it says that 1 plus 0.33 U2 for brass. Since we are working with alpha alpha, that will be the equation, right? Are you seeing why U2 here? 1 plus 0.4 U2. What is U2? Wind speed at 2 meters from the ground surface, right? Now, do we know the wind speed at 2 meters? So we need to find that from that logarithmic profile. Okay, so we will do that as quickly as possible because we already know how to do that. So let's work on that very quickly. Just make sure you know the equation. Okay, so that is the wind velocity profile, right? Here. So at z equals to 3.66, what is the u? It's actually 2.48. Okay. And we are trying to find the velocity at 2. So what do you think? Velocity will be less than 2.44 or greater than 2.44? Less or more? Less, we know that, but we just don't know the magnitude. So we will work on that. So determine U2. This time it's real U2, okay? So U2 equals to U1 ln Z2 minus Z0 ln Z1 minus Z0. Now, U1 is U at 3.66, right? Z1 is 3.66 meter. Z2 is 2 meter. But I don't know the Z0. Is there any variable or relationship I can use for Z0? Z0 is the location where the velocity is 0. 0.3, yeah, I think it's 0.3 or 0.03, but we need to check the table first, right? Okay, so you think this is the table we can use? Table 3.1. We are not working with open surface. We are not working with open terrain. Are we working with open agricultural area or agricultural land with houses? Maybe this one because there is no information about the house or anything. To add some tricks on your question, I can say we are working on agricultural land with houses or village, small town, forest. So you just need to find out what will be the Z0. Okay. So for our case, what will be the Z0? Okay. It's from table 3.1. So I will write down that. Okay, now find out this. That will be 2. What is that number? One second. Something similar to that, like that. Okay, so I will write down 2.17. Great. Now I can work with RS and RA, right? So if you go to that page number 3 on your copy, you will see equation 319 is 1 plus RS over RA this one. And what is that value? $1.868. Okay. We also need one RA value, right? For the equation. Here we also need RA value, right? So this part is done. Okay. So for RA value, is there any equation I can use for RA value? This one is for RS and this one is for RA. Again, we need U2, right? So that is the equation 3.18. Plus, please make sure you write down all the reference here. Otherwise, it will be too much. So RA is, what is the equation for RA? 110 over U2. What is that? And all of these, when I said equation 319, 318, it's actually Gupta 4th edition, your textbook. Okay, what is RA you got? 69? Oh, it's 3.69, right? Okay. So I think it's second per meter, just the opposite of okay. Now if you look at the original equation, we have almost everything except what? Rn, right? Now we have minus 12 minutes. We will need that 12 minutes, maybe less than that for RA. So what I will do, I will write down the equation, very basic equation, and you will calculate the Rn, okay? You can use your old class examples for 16, I guess, just to understand the steps, or you can directly use if you can remember all the steps. But are we good with RA and RS, everyone? Okay. So the next one is determine Rn. Now that Rn, it was the net radiation, which was the summation of net short wave radiation, net long wave radiation, right? So we need to find RNS RNL. Okay. So I think you need to use your previous class lecture, that evaporation class lecture, energy balance method. So RNS is 1 minus alpha 0.25 0.5 n over n RA. Okay, don't worry about the RA right now. Work with all the other parameters. We will discuss how to find the RA if it's not given. Negative 0.1 plus 0.9 n over n 34.14 P E sigma e to the power 4. Okay. Now, one thing that ED here is actually EZ. Like you already have the value for EZ. And that sigma, that is actually Stefan Boltzmann constant. Okay, I will check with you at 10:45. Okay. This was everything except RA, and then if you have time, what is RA? I think you need to use your class lecture from evaporation using energy balance method just to find out all the values for alpha, sigma, and everything. Yeah. Exactly. Yes. Like 0.825. Yes. And over n. So here is the here is that mean percentage sunshine. That is basically that n over n. So since it's in percentage, it's better than 0.8. 0.825. Yes, yes. N over n is actually that percentage of sunshine. 0.4 is actually for the water. The water. Yeah. You have that concept here? Yeah. Zero because here to one here. Yeah. 0.23 for the total gas, 0.084 open water. What will be the value for alpha here? 0.0.83, yes. Because we are working with mass, right? For the water surface, it was 0.0. 0.23. No. Alpha is the name of that alpha. And alpha is the name of that plant here. So too many things. Alpha is the name of that plant. So just a bit later alpha. Kind of the evaporation by energy balance. Okay, you have 2 minutes. Work on that. I will check with you after 2 minutes. Make sure you use temperature to be about 4, and temperature should be in Kelvin. All of you have class number 19. Two extra. Usually I have one extra. I have, let's check. Where did I calculate roughly? 20.8. You got something like that? Okay. Okay, class. So I think you have everything almost except that RA, right? What is the RA? Extraterrestrial radiation, right? Now, for our previous class example, R was given, but this time we don't know the RA. So what we will do, we will find out if there is any table, because right now we can use the NASA website or we can use some table. Obviously the NASA one will be the most accurate one, but the table will give you pretty accurate value as well. It's just the average one. So do you think we can use table 3.3, all of you, for RA? Okay. So do you know in which hemisphere we are in, northern or southern? US, actually, northern hemisphere, yes. And we are working with July, right? So I will separate the July. And what is the latitude for that Idaho, that city? So 42.4, that will be in between these two, right? So I'm giving you the value, the interpolated one, RA at 42.4. The value I got is 40.8 megajoule meter square per day. Obviously, I did the interpolation. For each test, you need to do the interpolation. But just to save some time, I'm just giving you the value directly. 42.4, right? Are we good up to this point? Everyone? Okay. So what I will do very quickly, I will just use all the values I have here. Now, you tell me what will be the alpha? 0.23. I will just make a note. 0.23 for crops, 0.08 for water, right? Okay. 0.25. What is the N over N? Okay. And what is the RA we just got? 40.8, right? Find out that. Now here, 0.1, 0.9, 82.5 over 100, 0.34. What is the EZ we got? 1.24, okay. And sigma is the Stefan Boltzmann constant, which is a very small number, 4.903 10 to the power 3. And the temperature we got 293.9, right? To the power 4. Okay, what is the number you got? Okay, we have 2 minutes. I think we can finish that. Aiden, what number you got for small wave radiation? Okay. And do you have anything for RNL? 5 points, negative 5.61. Okay. Anyone else got something close to that? Okay. Plus, can I have just 1 extra minute so that I can complete that? I will just need 1 extra minute, okay? So that RNS and RNN will be 5.65 equals to, what is that? 15 point something? What number you got for RN? 15.13. Okay. Now we have everything. We just need to plot everything on the equation, and we will again start from this point, but just for now, I'm just writing down everything here, and the very final answer you should get from this ETO is 7.1 into 10 to the power 3 meter per day equals to 7.1 millimeter per day. Okay.